Right, so what's here? Right, so if we had to summarize the whole process, the whole photoelectric effect. Huh? If we had to summarize the whole photoelectric effect. Right. If we had to summarize the whole thing, right? We could have just said this: the energy supplied by the incident radiation, right, goes towards breaking the bonds of the electrons, which we call the work function, and the remaining energy acts as kinetic energy, right? So when the energy is supplied, the electrons will break the bonds, and then the remaining energy from this is the kinetic energy, right? And it could also be written as this: HF is equal to HF naught
plus a half mv squared.
or EVS. I'm doing this version, right? This is what we call the stopping potential. What was that again? The reverse potential, that what?
That
stops the electron from leaving the other side. It's also synonymous with the maximum kinetic energy. So the stopping potential gives us an idea of the maximum kinetic energy of the photoelectrons. All right? The maximum kinetic energy of the photoelectrons. What's F naught again? Nikila, F naught is what? Which is the what? Minimum or maximum frequency? The minimum frequency. Right?
I thought threshold was
Now in this case, threshold is like the smallest. But you see, but yes, to be honest, sometimes it's be like that, right? But in this case, threshold frequency is the minimum frequency. The minimum frequency that allows photoelectric effect to happen.
right, okay.
But anybody remember a formula that links frequency and wavelength?
Yeah.
Anybody remember something that links frequency and wavelength? Because V is equal to F lambda. So in this case, our UC is equal to F lambda because it's speed of light, right? Most times it's incident, is some measure of light. So it will be H, we arrange here, C on lambda. So I could also find the energy by doing this. Correct, Timothy? And I will get H C on lambda naught plus EVS. This lambda naught, as Nikolai was bringing up, this lambda naught is the threshold wavelength. Right? But the threshold wavelength is the maximum wavelength that allows the photoelectric effect. Have you done something now?
Esse vai Soraya, Naya, Nikolai, nobody come to class. I said, I have to show you that.
No, you didn't tell me. I didn't see them. But I was Soraya and
yeah, they look different.
No, I didn't recognize that. I didn't see you one. But I was right next to my wife. She was right next to her.
What?
Yeah,
That's like a problem.
So you want that?
So you want to see Steve?
Yes.
Okay. So photoelectric effect is a nice little summary of the whole thing. And we're going to try to put it together into past papers, right? But I just want to point out something here, right? Someone already. I want to point out something about joules and electron volts. Right, I want to point out something about that. Then we can do that. We can do the graph versions as well, right?
So much about this one.
And look at that one again, everyone.
Yeah.
So if you want to leave out there, you can
He's
be
not very dark. Somebody else do it. Thing I can see that.
Like, bro, I don't do it.
Teacher, yeah, I recognize probably. Teacher, me have to change that.
That's my favorite.
That week, send me the mind that.
Kasi mga take risk, kita mga mga episode.
No,
Kaya hindi, yun para.
Right? Oh yeah, I wanted to show you what's the relationship with a joule. What's the relationship between a joule and EV? Electron volts. I like it because why right, so you gotta right, so watch here. Watch here, right? So you remember this formula? W is equal to QP. Remember that formula?
Yeah, so you did give us.
Right, so watch this here. Nalia, watch this here. 1 joule is equal to what's the charge of an electron?
1.6 by 10 to the minus 19.
1.6 by 10 to the minus 19.
So that's 16.
Sorry. Right? So 1 joule is equal to this. Okay? Let's give it to you, I think, but
And that is electrostatic.
so sometimes if you see that's how I'm gonna study. Sometimes just give them mega electron volts. I can know my
So, apa?
Huh?
You know, be like a lady.
She right behind us?
Really?
What's your video? You see right behind us.
Yeah, no, we look
But it was right there.
So that's probably be out of the parents.
Oh. Did them sure?
But she doesn't see any cap box out there, like, why don't you know? She talk when cap back here, bring 6 pack out road boy. I see she watch us today. We think fast to us to
And that's wrong.
Right.
That was
All right, this is back to front. 1.6 by 10 to the minus 19 joules is 1 electron volt, right? All right, then back to front. Right? You see, one of the problems here is that electron volt, some of these values that we're going to be dealing with here are real small. So we need to come with the next unit. Right? So the next unit for these small values in joules is electron volts. Right? The wrong way. Sometimes you might see mega electron volt. Mega is how much?
10 minus 10 to the power 6.
10 to the power 6, right? So sometimes you might see it in mega electron volts. Okay? So for example, if you see something like this, just a quick example, right? If you see 3.2 by 10 to the minus 19 joules, right? Right, just divided by 1.6 by 10 to the minus 19, and you'll get 2 electron volts. Okay? And if you want, the other way around could also work. If I give you 2, multiply, and you get the value in joules. Okay? As I said, sometimes they might see mega electron volts, right? This is mega EP. All right, so let's see if we can attempt one. Huh?
Yes, right. Sit down. This 1.6 by 10 by minus 19. W is.
1 joule. 1 joule is 1.5.
Is it in my?
So W is one.
So basically, what I was showing you here, when you multiply the Q value by V, you will get a conversion, something like this,
Okay.
right? So one of this is equal to 1.6 by 10 to the minus 90. So I kind of write it bad. I meant to say 1 electron volt is, when you multiply 1 volt by 1 electron, you'll get 1.6 by 10 to the minus 90. And that's in joules, right? I went the other way around by mistake. This more can I'll keep this.
Why is that standard? No, it's not me. I don't mind watching that.
I think I'll still not see it. I have to think right away after I talk to you. I can't get my.
All right, first one, there's a graph, you'll catch that, right? Right? Right, so what you have there? Let's try this multiple choice first. The metallic surface,
So I use this.
3.8 electron volts. 3.8 electron volts. The one with threshold wavelength.
So let's try.
How are we doing that? One on top might be minus 9.
It's a.
Oh yeah, work it out. Threshold wavelength means you're using which of these formulas here? 1, 2, or 3? 3. This one here, right? HC and lambda naught, right?
Okay, well, I wrong.
Right, so you're using E is equal to HC on lambda naught. I'm gonna write that, I'm gonna write work function. Oh yeah, it's also lambda naught.
H is one.
Yep,
So while I get working with.
why they give it E? Right, but you recognize they give it the work function in what? Electron volts, right? Yeah, they convert the joules and then plug in H and C.
So lambda naught is complete or is with done with function is given. With function.
Yeah, work function. Wait, no, wait. Work function is this. All these are work function, but they give it instead of they give it in joules, they give it in EV.
So what?
So you have to convert EV to joules.
Right, but what is that? Lambda.
It's a.
Watch.
I don't know.
Why
What's
don't-
a substitute? What variable to substitute? To the EV. I understand I have to convert it, so,
The joules, right?
but I don't know.
And that will make it work function.
The entire thing.
Yes, yes.
Oh,
Huh?
So therefore, let's be 3.8.
That's a joules value. That's now your work function. Right,
yeah.
now-
and-
Now we have to plug in H and C, right? H is how much?
H.
Yeah.
6.63 by 10 to the minus. Big.
Right?
Start.
Yeah, and C is what?
Yeah.
C is.
Speed of light.
Right.
3 by 10 to the 8.
Okay.
And the work function is what?
4.2.
Well, 3.8 by 1.6 by 10 to the minus 19. Right? This is the work function.
So that 3.
Listen,
Never mind, I understand. I divide it.
divide what?
I divide 1.6 by 3.8.
Oh no, that just show it up, right?
I do what that makes it up.
See.
And then. Very good.
Well, again, see, right? But remember, the answers is normally, I think normally dealing with light,
Yeah.
so it's normally a nanometer. So you gotta guess that. That equals the nanometer that we have. 10 to the minus 7. Come on. Guess. Okay. Right, the threshold wavelength, because is the maximum wavelength or the minimum wavelength? Wait, it happen. Maximum wavelength. Guess that. No, frequency is minimum. Wavelength is maximum.
Okay.
Yeah, sorry. Show you what? Nelly, again.
So I have 3 minus 7.
Yeah, that's
Oh,
the
that's
correct
right.
answer.
You play nice exacting.
What do you say?
Wait, exactly.
Landed the question.
So the King's program, what that is,
Chandler, array plus field.
Even multiply 6 points by and it's 19, man. 19. So most likely you would have gotten 6.08 by 10 to the minus 19. Right? But remember it's minus 19. Let's go again.
Me too.
I think. And it's
I, all right. Ignore the first part because you all don't know what de Broglie has yet, right?
they broccoli, they broccoli.
De Broglie.
Hey, you think I wanna give one?
That's the PNC.
Great mind think that. Like, where was it?
Let's do B and C. But now, I'm just checking, please. You're doing work for the first time. Come on. Right? Let's start with P.
Then I answer, I had a little bit of this class, but then I answer.
So you have the work function Soraya that I don't mean way before. Find threshold wavelength. We just did that, right? Because what are you doing? Oh. Find the threshold wavelength. Let's do it piece by piece. A little bit different. And then
Yes, that way I said.
basically the same thing you're doing. Take your time, right? Work out all the parts online. You'll be nice. Oh yeah, find threshold wavelength again, and then they want to define the maximum kinetic energy.
So Planck's fundamental 6.6 by 10 to the minus 34.
Yeah. Take your time, I'll do it piece by piece. Try and see if you can do 1, 2, and 3. Everything you need with a little summary that we did, right? Everything you need. All right, that's
Yeah, back.
Yeah, we have three parts. But what I need like a line, if I can. Yeah.
Yeah.
I just think that. Yeah, I'm not It's equal to. Yeah, right.
Oh, ngày thì không lại liệt sĩ của bạn làm là nó
But then what's not?
làm là nó chưa nó phải
We, yeah, we find already, but then what's not done?
phạt ấy nó phạt cái này
Yeah.
we just on the phạt rồi đúng không? We just phạt cái này
Yeah, it's just a
Part one is find out the rule.
yeah
Yeah.
cho nên cái phạt nào
5.65 by 10 to minus 7.
Yeah.
it's still about it
You can see it all wrong, one month.
Yeah.
làm là nói thứ của cái kiến siêu bảo
HC over.
With function.
Yeah.
IO
Yeah, yeah.
IO frequency full function
That's good.
cái phòng này của trường phạt phụ huynh phải phạt nó just in siêu bảo ai well I provided I zero take that just to good function
Where do you pass out of that? That's crashing up the one.
Oh, together.
Oh, so they
oh we're just gonna find EK so EK would be equal to E minus I zero
Yeah.
and that is before the I zero
It's 3.5.
well let us be equal to that because it's equal to
Alright, let's see now. So which one? Part what?
I know, I love everything.
And what else will give you the energy at the incident?
So that's the.
Alright, yes now. So part one is just like what we just did, right? Part one is technically what we just did. Threshold wavelength is equal to threshold wavelength is equal to the work function over H by C. No, sorry, we are wrong. Sorry. H by C over, right? H was 6.63 by 10 to the minus 34. C was equal to 3 by 10 to the 8. And the work function, they give you the value in electron volts, so you multiply it by 1.6 by 10 to the minus 19, right? This here is your value in joules. How much you end up with?
5.65.
Final answer.
Yeah, 5.65.
5.65 by 10 to the, right? And that makes sense?
Yeah, 6,
But
7.
it's 6.5.
Yeah, no, it's
5.65.
Yeah.
Right. So
Yeah.
that is the minimum that is the maximum wavelength that would allow the photoelectric effect to happen. That's maximum, right? Okay. 5.65 you all said, right? Now, the maximum kinetic energy of the photoelectron when illuminated by that wavelength. So if they give you the wavelength of the light coming in,
I don't know.
how are you going to do this? Look at the first equation I gave you.
Yeah,
And that will help you find kinetic energy.
yeah,
The energy of the incident radiation minus the work function.
yeah,
Correct?
yeah.
So how do we get the energy of the incident radiation?
It's easy because it's.
Right, HC on lambda and your minus the work function. Everything has to be in electron volts. That's okay? And if you have the maximum kinetic energy, how you finding some potential?
Well, like that's the
So-
you're divided by translated.
Right. So therefore, maximum kinetic energy is equal to EVS, right? And I'll show you that on the board. Okay? I showed you that stopping potential gives you maximum kinetic energy. Okay? Watch here. Stopping potential, which is stopping potential by E, is equal to your maximum kinetic energy. So these two things equal. Sorry?
They give us a branch. They give us we don't have is it C over lambda.
Sorry?
Let's have no F in it.
It have no F to wait. Remember, I look on the board. I gave you three versions. E, the one with HF, and the one with
So EK is equal to some potential.
EK is equal to by what's it? EK.
right. EK is equal to the sum potential. These two things equal. Work function equal to HF naught or HC on lambda naught. HC is
Plan constant by speed.
Planck's constant by speed of light. Those are the constants.
0.63 by 10 3 minus equal by 3 by 10 3 6.63 by 10 3 minus 3.
I work it out, yeah. For what?
Potential.
Yeah.
I guess 0.0.9
I thought it sounded funny.
0.9 0.
I know. I will do that some online. Any answers? Anybody on any we can trust? To be show online. Nope. We can trust them, man. Round you.
Yeah. So you sleeping or not?
Wait, no, I got 1.4.
Yeah, we are.
So they are not going
Charge
on.
of electron.
You know what's going on?
Yeah, we are going to divide by charge of electron.
So why to right?
They didn't ask for that. They give them two.
No, it's big.
If they ask for 8 electron volts, yes. How much you all got? What do you get up? 1
Yeah.
point.
425?
Yeah.
Yeah. 425. Yes, sir. That is simple.
By 10 to the minus 19.
Yeah.
Just plug that whole thing in the calculator. You work it out?
I couldn't remember about it. I don't know about it, but I just divide everything by 1.6 twice. Well,
Yeah, no problem.
So like to else we've done, I would be surprised if you guys. No, and then I said, she was no, like that's said about.
So you all got 1.4 what?
4.5, 4.45.
1.4525.
Every time you see that, you're like,
Wrong, not the work functions.
Quite nice.
1.4525, right? Everybody okay with that?
Yeah.
You got that now?
Yeah.
Right. Quick question, right? What would happen if the value was negative?
Therefore, the charge is up back up. Yeah. Voltage up up.
What would happen if the maximum energy was negative?
Maximum energy.
Yeah, so where just work out there? The maximum kinetic energy, right? Suppose you work it out and you get a negative answer. What does that mean?
That's one more voltage.
Energy, I don't know how you mean voltage.
Energy.
Huh? So if it's negative, does it mean it has energy? Huh?
No.
No. So a negative sign there would indicate that this process cannot happen. Right? Because the electrons don't have enough energy. Okay? So it means that the work function, that's this value here. The work function would have been larger than the energy being supplied. Okay? And if the energy being supplied is smaller, then
Yeah, for that
it
value,
can't happen.
that value we guess is how much more energy will function.
No, that value works out there.
So if it was negative, right?
Yeah. How
How
much
much
more?
more it would
Not the
function?
work function, that are standard value. How much more the incident radiation is. Okay? That's how much more the incident radiation is. So here's what they asked after. Right? Ariane, answer this one. Explain whether or not red light will cause electrons to be emitted. So your first thing that you have to figure out is what's the wavelength of red light? Sorry? 623 nanometers or 6.23 by 10 to the minus 7. So question, look at that value. Will that value create a photoelectric effect?
Yes, it's more than the makeup.
Ariane, don't let me set you up, you could be wrong. I feel you wrong. Look at the wavelength of red light. So it's now being incident with red light, right? What is the threshold for sodium? By 10 to the, what does threshold mean? Threshold wavelength is what? Maximum. Threshold frequency is the minimum frequency. How do you remember frequency and wavelength inversely related? Right, look at the formula here. 1 over. So, Ariane, my question is, if the wavelength of the light coming in is 6.23 and the threshold is 5.65, would the whole process happen? Why? Read about the threshold and tell me what the threshold means again. Threshold wavelength means what? The maximum wavelength that will allow the photoelectric effect. Maximum, right? Huh?
Is this, that's the next one.
Oh, which one bigger? Right. So 6.23 and then larger.
Yeah.
So it's exceeding the threshold. So what will happen? It will not cause the photoelectric effect. Okay? So no, it will not cause the electrons to be emitted.
Yes, by 6.2.
No, 6.23 by 10 to the minus 7 is bigger than 5.6
Oh,
by 10 to the minus 7.
yeah, that's smaller. And that'll be 0.005.
Right? Ignore the minus 7 because they both equal, right? Will not cause the electrons to be emitted from the sodium. You only work out partially. I make a mistake and skip it. Right? But since you bring it up, Divish, what's the formula we're using for start 3? EK is equal to EVS. So VS is equal to EK over E. What is that? He wants the song.
This is my summarize already.
Because you're
mom, why you were in my dog, they go smart.
I was in class.
What you all got for VS?
0.908.
Point
908.
0.90.
Yeah, but it's so here's the money.
Look at the side.
Everybody okay with that? So this, Ariane, earlier, I want you all to understand the difference between wavelength and threshold wavelength and threshold frequency. Alright, Deepanju, tell us. What's the difference between threshold wavelength and threshold frequency?
Inversely related.
Yeah, the
Right.
threshold wavelength will be at maximum. Threshold frequency is the minimum.
Frequency required, right?
Yeah.
Next one.
So anyway.
Wait, it's the same thing we do over. That's not fine.
He was a
Maybe critical.
Yeah, like-
Try this one yet? Quick multiple choice.
It's like I'm squatters, it's like, oh yeah, just my line now.
It's way back.
Alright, I have a little problem with that one. You need to do the graph, right?
It's like,
Oh yeah, do this one please. Nalia, can I get one right here, please?
I get one right to five. The coverage.
Oh yeah, try this please.
yeah, I think so. You just have to call and you find the big transfer frequency. Zero. We have each is probably like 6.6 by 70 minus. Multiplied by yeah, that frequency not agency. So you have H.
Yeah, right.
Yeah, I think that's all.
Already?
No.
So they want you to find work function. Oh, nice one. I like that they break up this. So what they give you?
Stopping potential.
Stopping potential, and they give you the incident light frequency. Okay?
Yeah.
So look at the formulas 1, 2, or 3 and see which one they're going to use. Nalia. Nalia. 1, 2, or 3, which formula we using? Okay, ma'am, tell me how to find work function.
It could be equal to.
Which one, ma'am? 1, 2, or 3? Rearrange 1. You're close, but I don't like that one.
Wait, so you have,
Right.
you
See, you can't rearrange 1. Do you have kinetic energy? No.
but we have some.
So what about the second one?
Yeah.
Right, so rearrange that instead, right?
So where's that F value then?
So you'll get work function is equal to H F minus EVS.
Yes, sir, that F value, that's right, that's the F to give you the question.
F is the, think about it. F naught is the what?
The highest,
The lowest
lowest, sorry.
threshold frequency. Did the question say threshold frequency? What is that? Frequency of the light.
So therefore, that will be the
So
question.
everything here, everything on this left hand side here is the incident radiation. Right? This F is for the incident radiation. This lambda is for the incident radiation. Okay?
Okay, good long.
Hurry up, work out the work function. Follow it now. Sorry. Follow it now. What again? Nalia, what again? A, B, C, or D? A, B, C, or D?
D.
D. Nalia.
Phải các bạn chạy được.
Yeah, as a that.
Rated out Nalia.
Ada di. The reaction is people are not bad, but you like usually kind of come down.
Yeah, no, that's. It's really like the one.
What's that again?
You feel like
Huh?
like a flag.
Dog, dog, okay, nice. Let's go again. Everybody okay with that? Let's go. Let's see if Benaya will go on here. Find one for you here. Alright, we'll do the graph test now, right?
Ew, no.
But yes, it's the one.
Yes, no.
Even it's already yes, yeah. Alright, I know you all can see this, right? But take a picture of the graph now.
It's good.
So it's kinetic energy versus frequency. Kinetic energy versus frequency, right? Kinetic energy on the Y, frequency on the X. So what we have to do with the equation here?
Find the gradient.
What we have to do here, rearrange, right? Put it in the form
Y is equal to mx.
y is mx plus c. So rearrange the equation, put it in the form y is mx plus c.
F is equal to E on H BS plus F.
Now, I don't know if I gave it this version. This is frequency. And this is kinetic energy. So rearrange HF is equal to HF naught
Plus
1 H is the frequency.
plus kinetic energy.
1 H, sir.
Sorry,
1 H.
is the one.
yeah, LB1 on H gradient.
The gradient.
Gradient is
1 H.
It's going to E. It can't be if I equal to be uses E.
The gradient. The last one was frequency about EBS, right?
what's the y-axis?
Frequency. No, it's not
The y-axis is kinetic energy, right?
Oh, it's
Oh, yeah, so you have to switch around.
Yeah, it's kinetic energy on the y-axis.
That's what GHTT. No, because people don't think that's all things, but it's because when I started in front of the school, I got sick gas so in front of them, so that's all done. But the carry no way.
Did you see?
All of this being like, what they do, and going back and forth.
So did you see?
So what we get here, so that rearrange,
So this graph going to the origin? Go.
no. So you're going to get kinetic energy on the y, and I'm moving across HF naught, right? I'll get HF minus HF naught. Right, so kinetic energy is the y-axis, F is your x-axis, so your gradient is what? Your gradient is H.
Now I was seeing.
And your y-intercept is what?
Minus H.
Which is technically your, who thinking there? Very good, Arian. So look at the graph, Arian. What is the work function? Look at the graph. What is the work function? Wrong. Gotta be careful. That's a common mistake I told you, try to avoid. He said -4. But why is that wrong? Very good. Right? Oh gosh, boy, what you get wrong? Right? Right, you have to read off the units. Right, Azaria? You have to read off the units, Azaria.
So I was sure of that. She wanted something else on.
So it's minus, so sorry, 4 by 10 to the minus 9.
I don't think she would be vexed in that case, so that's period.
Okay, 4 by 10 to the minus 19, right?
We can find already, you know.
Well, you have 2 in here. You can find F naught straight from there. You can find H straight from there.
Yeah, but we find out already too.
Oh wait, hold on, let's see what they ask for. They ask for threshold frequency, work function, Planck constant. Try those now, please. Right, find threshold frequency. Yeah, threshold frequency and so on. Tell me what you get, please.
6 point.
You have to find threshold frequency, work function, and Planck constant. And that was the last thing, Planck constant.
5.98. I get the go of it. So that's not so I think really I think why exam so each have everything.
Oh yeah, work it out. Nikhil, work it out.
Yeah.
And the 5 each and that's also. You know, each. Really big for my
This is not very boring.
that was so basically so you are like you are right. So rather than being a question.
Yeah.
All right, so
If you have broken on me or
what we get earlier?
you
Earlier, you know what's going on? What you got? Sorry?
so is it next year right?
You have to find threshold frequency. Right, so work function is equal to HF naught. Oh, you all got threshold frequency.
HF don't see was an average.
Alright, so that's one option, but what about reading this value of?
Yeah, no, it is still going to get answer.
By
Because if I get 5.98. Oh yeah, that's correct. We will not get exact values.
so what?
If we read off that, we got
Wait, remember we don't know which.
we don't need H is principal.
Nobody asked to find that later on.
We do it. We do it.
Huh?
We do it with this.
We don't know it. So, right, but it should be close answer. You should get F naught from right here.
Listen, I get the exact same thing. I get 0.59.
Right, but if I read off that, how much every block is?
1 block is equal to 0.025.
Point each small block.
0.0025.
Yeah.
So it's 0.5 divided by 20.
So read it off from there now. Let me see if I can read it off as 1, 2, 3, 4, 5, 6, 7 blocks.
So what that will be
Go up the calculator.
0.175.
Huh?
So it will be like 0.175. There will be 0.675.
Right, so from reading off here, and we have to use this value earlier. From reading off there, F naught is equal to 0.67 by 10 to the 15. Right? That's the threshold from the graph. The work function, we just read it off. The work function is 4 by 10 to the minus 19. And then find H. How you getting H? From the graph. How you getting H from this graph?
Divide that value by
No, from the graph you have to the gradient.
yeah, we divide that value by gradient.
No, you just find the gradient and that's H.
Oh, the gradient. Oh, yeah.
right? So find the gradient coming up.
What's
Oh yeah, find the gradient.
I can't read off that here.
Very bad.
That gradient really hit the pipe.
You see,
But anyway, you'll follow y is gradient.
Yeah.
Find a little hard to read off for
The
you.
gradient is equal to h.
So the gradient is h, the work function, right? The work function is the y-intercept. And then
this,
from that, you can find f naught there as well. But you see, this question asks you to find h. So you can't use h. You can't use it as 6.63. Okay? But when you work out the gradient, you should get something close to it. All right, let's go again.
Yeah, very done.
Now. You're almost done. Oh, yeah. You can rearrange this one here, stopping potential versus frequency. Don't draw it. Just rearrange and tell me what the gradient and what the y-intercept.
The frequency is one axis.
Yeah, once you see f is the frequency from the incident radiation.
And that could be one axis.
No, in this case, the x-axis. Stopping potential. No, don't plot the graph. I just want to linearize. I want you to take the second formula and linearize it. Tell me what's the gradient and what's the y-intercept. Hurry up.
H one is the gradient.
Look it out. Take the second equation and rearrange it. That's what I'm about to take it. Equation, then let's take it back.
yeah.
Hurry up, rearrange. Rearrange the formula there for now. Rearrange the formula and put it in the form y is mx plus c. Put it in the form y is mx plus c now.
So you want to see that before?
No, I don't want to see it. I don't. I don't answer.
Well, then,
Uh,
like, I think we're gonna be-
Rearrange that for now.
Oh, I don't have to do it. I have
H
to-
one is the H one E, H one E.
What's the value?
Okay, look, hold on.
Yep. And in y the surface H x goes on. By us H.
I gave you this one already. I realize that.
What?
I think I gave you this one last one.
Yeah, you did. I guess equal to EHPS plus that one. You don't need.
Right, so Vs is equal to HEF minus HEF naught. So that's your x, that's your y, that is your gradient. And this value here is your y.
Wait, I was still learning the story with Raj. So when you ask for the story with Raj,
read it?
Okay, well, this one already?
yeah, we just do that one, yeah, so it's 1.7 by 10 to the minus 7. Yes, so here is right. So we do that math exam, right?
Find that.
Try this one. Yeah, I'm here.
Okay.
Nalia, this one here. Vinaya.
Just, fix it, yeah.
Nikolai, last one.
I think we
So
got
I
that.
thought I learned the story. So here we see, you graph it out, complex numbers, right? So as far as what I know, with a circle, we get it wrong, right? Like, I will plus that we can read. So Raj, you know about geometry class, you have to have protractor. So we want to know, we give our protractor. Then you realize, well, if you are after all guy, you know, but we don't need to draw after you tell us. But we are not understand. Okay.
That's the front runner.
You didn't see the protractor. I think after the protractor, everybody in the class watch like, Why we need that track that phone?
Right, last one here, last one. Oh yeah, last one. Oh yeah, last one.
Right.
What if anything?
I know, but I'm saying like stressing out on me.
HF dot is equal to 6. Hey yo, Raj Malayo.
Soraya.
You're gonna
You got that, it's Soraya.
Disease. So what happened and I go, why is it so mean today? Like did this
So the answer is the boy.
I'm back. No. Because your wife wants to go out. You are so bad.
Oh yeah, last one.
Smile economic opportunity.
So you're going to your time.
Needs time. Miss always. Yes. Always those you. No. Yeah, why but I don't care. Let me see. This one.
So I got the answer. Okay, hold on.
Right, so what they gave us the work function and they want the minimum frequency for the electrons to be emitted. What they asking for, Timothy? What they asking for? Right, so F not equal to what? Sorry? Work function over H.
That's
Right.
right. D has a.
So that's 6.4 by 10 to the minus 19 over.
So any answer is B.
Yeah, that's B, sorry, yeah.
Right, B. All right, nice.
9.6 again.
Individual. How we did not. All right, next one is a graph.
No, I seen like a reinforced. She jumped. Best performance.
Last one, so the one and we done. Last one and we done.
So actually last.
Now. Last one and we finish.
Yeah, there's the 8.
Okay.
So we do first show one is out. The answer is D.
Oh.
Nikila, this one is yours. Why? Nikila, explain this.
Let's say light frequency carrying higher frequency. Okay, trustworthy higher is it B.
I don't know.
Therefore, one carry right to your one trustworthy frequency is the above. Okay, well,
I think there's not. I get it. Well,
Hurry up, Claudia. Hurry up.
that's okay.
I want to hear the answer.
yeah, one and three C.
I think it's B.
So, I will give this one.
Yeah, wait. What's the answer?
C.
Wrong. Wrong.
But yeah, you have it in.
Huh?
A.
Why is B Arian?
E.
It can't be D. One correct.
Why is D?
Yeah, because you have to be greater than the threshold because remember threshold you know it's variable frequency.
Threshold frequency is the lowest beta one, right? So is one correct?
Yeah.
So
Yeah,
photoelectrons are emitted from the surface as soon as light greater than the threshold is incident. And that's true?
No, then there.
Olia, last one here, please.
yeah, well, pay attention.
Last one. Is the first statement correct?
Yeah.
Nothing there.
No.
Yes, the first statement correct.
Yeah, one correct.
Once the frequency of the light is greater than the threshold, it will happen,
Because traction frequency is the lowest.
right? Why is two right or wrong?
Wrong.
Why? Because they are, no,
So the.
formula is not on the board,
Enough independent.
right? Intensity is directly related to correct. We talked about that last day, not today. And three is what? Is three correct?
No.
Read it properly,
The cutoff is very good.
I think.
right?
Yes.
Cutoff is the maximum, right? So anything,
But below.
But it's not below.
Below which.
Right.
Which is four.
no electron being emitted,
And
Yeah,
I'm
it's not four.
right? So the cutoff wavelength of the incident rate and the metal below which no electrons are emitted,
So that's wrong.
which is wrong, right? Right? So the answer is A.
I've been saying that.
Only one is
I've been
correct.
saying that.